Hello, everyone, and welcome you to 27th episode of Mojo for Industry Development Debate. And this time, the topic is machine tool monitoring and maintenance. Technology partner for this session is IFM Electronic India. Machine tools industry is one of the major pillars of the manufacturing sector. According to Indian Machine Tools Manufacturers Association, that is IMTMA, consumption of Indian machine tools industry by value has reached rupees 12,036 crore and production recorded rupees 6,602 crore during financial year 2020 and 21. IMTMA estimates that the Indian machine tool industry will reach around 9,500 crore in the year 2020 to 23. As you all are aware, the machine tool monitoring and maintenance system allows you to know the real-time habits of a machine, which enables you to take immediate action to improve the machine operability. And implementing a machine monitoring solution enhances the overall efficiency of your manufacturing plant. Today, in this Mojo for Industry Development debate on machine tool monitoring and maintenance, we will discuss on the importance of machine tool monitoring and maintenance. We are glad to welcome our distinguished panelists for the day. Today, we are joined by Mr. Maulik Patel. He is the Executive Director and International Business Development at Sahajanand Laser Technology Limited, that is SLTL Group. Then we have Mr. Rajesh, who is the Sales Manager, Bangalore for IFM Electronic India, and Mr. Srihari, he is the Senior Manager, IIoT Business Development at M2 Next, that is a subsidiary of PFW. So to take the session forward, I would like to invite Mr. Maulik Patel. Mr. Maulik will share a kind of overview of machine tool industry in India and will also highlight some of the benefits of machine tool monitoring and maintenance. Over to Mr. Maulik.
We are into 2D laser cutting machine, 3D laser cutting machine, 2D plus tube combination laser cutting machines, tube laser cutting machines, automation solutions. All of these are lasers. The epicenter is we use laser. All of these products, we use laser technology, except the profile bending machine or bending machine. Rest every of the solution has laser technology, handheld laser cutting, robotic laser cutting, welding, robotic cladding, hardening, high power laser welding systems for railways. We also make 5-axis laser cutting machines. It goes in, automotive industry majorly. Tube solutions for round, rectangular, square, any kind of a L channel or any kind of machines. All of these machines use very high technological controllers, and also it is equipped with a lot of sensors inside. So because of these sensors, we are able to monitor. I'll explain it more in detail that, how every of our machines is now. The new technologies are actually, equipped with all of these sensors and monitoring of those machines to make sure, our customers get the maximum benefit out of it. Apart from Asia, I think the world has moved to lights of operation where, there's one time a programmer just adds a program, put it on the machine, and the operator just selects one-time parameter, and then you're good to go. So all of the entire machine, takes care of its own, and then it does the operation even in lights of condition. So does not need a full-time operator standing there for any of whether a material change or nozzle change or tool change or anything. One of our solution, which I would like to show you live. So here what we see is, kind of a dashboard, a screen. We just selected one particular machine. When we go on that particular machine, it says that the machine is in an idle condition as of now. It is not in running condition. So, with this kind of a dashboard, there are different users. There could be a manager as a user. There could be owner as a user, operator as a user, or a supervisor as a user. Every individual is being given some sort of target, or there are KRA and KPIs defined for an individual. Based on that, different attributes can be given to different people. This is an overall dashboard of the entire equipment. There can be more data. So there are two sorts of data which we divide. One, which is useful for the OEMs, which is like us as a manufacturer. The second data is actually which is useful for the end customer. So when it comes to end customer, what they generally require is, what is my throughput, what is my output, and what is my cost. Based on this data, a lot of Analysis can be created. This is actually we give it on for the owners.
Thank you so much, Mr. Maulik, for sharing such thought-provoking insight on the capital machinery industry, laser cutting, and also giving a live demo of a machine monitoring system and how it actually benefits the end user. Ladies and gentlemen, Industrial Internet of Things or IIoT is changing the way industrial operations are performed today. Machine tool monitoring and maintenance is one of those primary areas that are leveraging IIoT. Now, we are joined by Mr. Srihari to talk about this topic of IIoT for machine tool monitoring and maintenance in details.
So Iris is an intelligent, reliable, innovative, and scalable product from M to Next. So that can easily connect and collect data from any modern as well as legacy assets. And through our platform, we can analyze and visualize any major KPIs and dashboards. And we have this flexible option of deployment on cloud as well as on-premise. So both options are possible. So this Iris Edge device will be able to collect data from any of the equipments in the shop floor. Like for example, a PLC-based systems, a CNC-based systems, a CNC, also any controllers, any Fanuc or Mitsubishi or Siemens, any controllers for that matter. So this device will be able to collect data from it, any industrial protocols, any OPC, Modbus, and any sensors in the shop floor. So this all-in-one device will be able to collect the data. Also some any vision applications that is Windows-based or Linux-based. So we have made this device with a intention in mind that OT is always highly available environment. So we cannot have any downtime at the OT layer. Hence, this device is curated in such a way that even if the power fails, this is having an automated inbuilt backup in it so that the machine, any operator interaction with this device will be continued. So this is made as an highly available system. And this edge device is enabled with multiple internet connectivity options, whether it can be a LAN-based internet connectivity or a GSM enabled internet connectivity. So this can collect the data and transfer the data to this on cloud at present. So because of the IT restrictions, because at the IT layer, there will be a lot of restrictions. So in case, if you prefer to have this digital platform on-premise, so we do offer this on-premise solutions of the Iris digital platform. And from the digital platform, this can connect to any of the existing MES or ERP systems, any of the existing systems. We have a mobile app as well for remote monitoring and so on. So all the data transaction between the edge and the digital platform will be secured. All the machine health parameters, which is analyzed on the edge platform, will be real-time available on the edge platform, that is on the device. And also in near real time, it will be also available on the cloud platform. So that is the advantage of this. So edge device is enabled with multiple authentications. So even the user-based authentication is given. And this device can be enabled with fingerprints sensors as well. And also this can be a kind of a biometric enabled or a face recognition enabled as well. So all these options, authentications are available on the device. So once operator logs into this device, so we can create the plan. So usually at present, there will be multiple job sheets in a form of a piece of paper, which will be floating on in the shop floor. All those can be digitized and the paper can be completely avoided in the shop floor. So whatever the planning we do, that can be completely done from the digital portal. So with this single device, we can plan the activity and we can monitor the activity. We will completely know the availability of the machine, the productivity of the machine, the quality of the job.
Thank you, Srihari, for sharing in-depth information on IIoT-enabled systems for machine tool monitoring and maintenance and how they are helping today's software professionals. Now, in this 27th episode of Mojo for Industry Development debate on machine tool monitoring and maintenance, technology partner IFM Electronic India, we would like to invite Mr. Rajesh Hari. Mr. Rajesh is a mechanical engineer, graduated from Visvesvaraya Technological University, Now he will discuss on some of the essential tools for condition-based monitoring and maintenance. Over to you, Mr. Rajesh.
We are from IFM Electronic, basically a German company into sensors and evaluation systems. We talk about this condition monitoring, and we'll be moving talking about what is condition monitoring, like reasons, maintenance strategies normally the industry follows. Say typical machine fault development, what are the technology being used, and what a vibration monitoring can tell us. What are the vibration problem, common vibration problems? How these vibrations monitor, like based on velocity or acceleration. And then, of course, condition monitoring not only depends upon the vibration; it's also about the oil. What we use, oil monitoring. So, what is condition monitoring? As all you know, it's something like in a short. If you say, it is to monitor parameter based on a condition, whether it is changing or showing any indication of change over a period of time, so that we get into the changing the part of the plant maintenance activity without interrupting the production or affecting the production in an overall scenario. So this is what it's all about condition monitoring. So what are the ways of condition monitoring? Like it says, like oil analysis, temperature measurement, machine performance or the efficiency, acoustic emissions or vibration monitoring. This all comes under the umbrella of condition monitoring. So what are the reasons for this condition monitoring? So what do you get? Like it could be like more efficient, like you can deploy your say maintenance personnel for this activity. You have a better planned activities like maintenance activities. So unexpected downtimes can be avoided. Like say you have a very much like reduced redundant plant, as you know, like you don't require an additional machine to compensate the running machine. Yeah. So some of the advantages as this the industry known terms like what we are discussing. So real time is something like where you get an indication from the parts of the machine when it has to be replaced and how it has to be done, so that you are in a proper plan, charted out a proper plan to replace the worn out parts. So first you start to analyze there is an excessive friction, yeah, then there is a noise, then there is a substantial heat, and then the smoke, and then ultimately the breakdown. Yeah. So where we start to monitor this particular problem is a key criteria to have a planned say maintenance activity of a machine. So what are the technology being used to monitor, how to monitor these things? So as you say, 80% is about vibration monitoring, 12 is around oil analysis, some of them are thermography and corrosion monitoring. These are the normal say ways or technology being used to monitor these particular breakdowns. What does a vibration monitoring tell us all about? Yeah, this as everybody knows, it talks about say misalignment, imbalances, yeah, bearing failures, looseness, or the say spindle imbalances. So all these things a vibration sensor can tell us in a real time values. Yeah. So what are the common problems faced is something like say unbalance, misalignment, yeah, looseness, bearing defects, gear meshes problem, belt drives. Then as Mr. Hari spoke about the crashness, yeah, spindle crashing impacts, fluid noise, yeah, rubbing. So these are the common vibration problems where a sensor can monitor. Velocity measurements to detect faults which exert an energy, yeah, such as an unbalance, misalignment, looseness, etc. With acceleration, we'll be able to monitor much more higher frequencies. We use acceleration measurements to detect faults that exert a force, such as small shocks, impacts that occur at the start of the bearing damage, gearbox faults, or pump cavitations, etc. So these are the sensors what we are talking about. So these are the online fault analysis systems. So these are some of the contents which I'll be skipping most of the things. Maybe certain things are already known in the market, and we can talk much more in detail technically about this product. And the second topic would be the oil condition monitoring. This is also a very important topic because we talk all about the vibration on, say, spindle or the motors or the pumps of the machine. What about the oil? Because water and oil monitoring and oil cleanliness is more important for the machine because it's called as a blood of a machine. Yeah. So when you say water and oil monitoring, what you're talking about? So when we say water and oil, it's about like it can lead to corrosion, wear and tear, deteriorating the viscosity, so these are common seen and common terminologies. What I feel that the industry knows about these things. So more is the oil, say saturation of the water in the oil. So less is your say bearing life, or maybe the say the overall life of a machine comes to say to a downtime probability. So what are the sources of this contamination of oil? As these are maybe because of say cleaning process or cap problems. There are so many factors affecting like what could lead to the water into the oil and like the saturation of oil. So these are some of the solutions what IFM can provide, like where we can provide a solution where the sensor can monitor the oil saturation level.
Thank you, Mr. Rajesh, for sharing your thoughts on condition-based monitoring and maintenance. So to start with, Mr. Rajesh, could you share your thoughts on how machine tool monitoring and maintenance impact productivity and profitability?
Main thing is that the mission has to be in a proper way. That is OEE, what we call it. It's overall effectiveness of the equipment. So everybody wants to be on the highest percentage of OEE as on today. When we are talking about Industry 4.0 and connecting the data to the server, all these things depends upon the OEE of the machine. So how to keep it of OEE of the machine is something like with the higher technology machine products, like to have instruments on the machines where you have a proper data collections, so that you are minimizing your breakdown. So as on today's day, if you see even the automotive and other industry sector, the cycle, the production per cycle has like come down like tremendously like anything. Yeah. So everybody wants to manufacture say within a second, or say few seconds, 3 seconds, 4 seconds. That's how the cycle times we talk about. So to get into this level, yes, we should have a minimized breakdowns of the machine, and we should have a highest of the OE of the machine. That's what I figure out to be like.
Right. I think Mr. Maulik will also agree on the same thing. Mr. Maulik, what makes actually SLTL's product or your kind of capital machinery, what you provide, what ensures the availability of maximum availability of your machines on the shop floor?
So just adding to the point on what Mr. Rajesh said, that every organization follows this, that what gets measured gets managed, and what gets managed will be improvised. On the same line, all our products have some other thing, where the data is coming from the product. As I said, we divide into two categories. One is the data which has to be managed for rather than the real-time maintenance to preventive maintenance, and then proactive maintenance. But there is one more data which is there, which is for the users. Okay, as I said about supervisor, manager, or the owner, okay, and an operator, wherein that is more on the production side, and the second data is on the maintenance side, or total productive maintenance, or whatever you say. So with the new technology and new equipments, what we have, which is starting from our e-tron series onwards, that's one of our product brand. All of these equipments have this monitoring system, gathering all of this data, and then improvising. We have an algorithm which is actually gathering all of this data and trying to identify those thresholds. And with this, autonomous learning or machine learning algorithm which we have deployed, the incident threshold point becomes closer and closer and closer and closer. So it becomes finer and finer.
Apart from helping this data with for the purpose of predictive maintenance or the monitoring, when you are going to get a huge volume of data, it will also help in, I think, future business planning as well. What I understand, Mr. Srihari. So because you are going to actually get an idea about how the machines are going to perform and what kind of availability will be having even in future course of time. So how do I like to address this particular aspect?
True. Like once, as Mr. Maulik was mentioning, as we have lots of data coming from multiple assets in the shop floor. So even the IT technologies like the new 5G technologies, which is coming up in the near future. So that should also support. So when we are advancing on the AI, ML, so from the past 10 years, this technology was in place, but the computation power on the hardware was not adding up or supporting us for the AI, ML algorithm, the shop floor. Similarly, once we have multiple data, so now we have the hardware assets to handle the data. So similarly, on the IT side, we need to have the technology which can collect the data and transfer the data in real time in as a huge bandwidth, so that we will have the complete ecosystem of the end-to-end. And my only point, or maybe a kind of suggestion to all the manufacturers, is just adapting or implementing IoT should not be the objective. So the objective should be to improve their productivity. So to improve the productivity, all these, the new automations or the industry 4.0, all these are enabling it, enablers for reaching our end objective.
Thank you. Thank you so much, Mr. Maulik, Mr. Rajesh, and Mr. Srihari for answering those questions, and as well as being a kind of very, very proactive panelist in this today's discussion. It was my pleasure having you here today. Thank you, delegates, for attending. We hope you have enjoyed this 27th episode of Mojo for Industry Development Debate on Machine Tool Monitoring and Maintenance, technology partner IFM Electronic India.
For more updates, please subscribe to our YouTube channel and press the bell icon.